Hi, I'm Eric from Energy. In this session we explain what makes our carbon-based hybrid power capacitor so special. As you know, batteries are energy storage devices. They store and release electric energy by way of a chemical reaction. And this is well known since the first lead-acid battery was invented more than 100 years ago. Today the most advanced batteries no longer use lead-acid, but they are based on lithium. When we use batteries, they also need to supply power. Essentially, the faster a battery can absorb and deliver energy, the more power it can provide. Lithium-based batteries are not very good at that, because they heat up. The more energy they can store, the less power they can provide. The current will heat them up, and in the worst case, they can even start to burn. This is an issue, because a car, for example, needs 10 to 20 times more power when accelerating or when going up the hill. Hence, car batteries are overdimensioned and heavy, with a complex thermal management system to keep things cool and safe, and the latter is essential for reaching an acceptable lifetime. As batteries are not very good at delivering power, maybe we can use something else. Supercapacitors, for example, are very good at delivering power. They don't store the energy in a chemical way, they store it directly as charged particles. The drawback, however, is they can't store a lot of energy. Now, if we think about it, what if we develop a hybrid energy storage device? Something that combines the benefits of a battery, storing energy, with the capability to deliver power, like in supercapacitors. It turns out that this is the best of both worlds. And rather than using lithium only, we use activated carbon as the main material, which means we also solve other issues like the dependency on lithium and hard-to-mine materials. We call these carbon-based hybrid power capacitors. They store as much energy as most lithium-based batteries, but can deliver the power just like supercapacitors do. What does this mean? Carbon-based power capacitors can store about 100 watt-hours per kilogram, which is comparable with the best of LFP batteries, but can be charged 10 or 20 times faster. Practically speaking, a 15 kilowatt-hour battery can deliver 150 to 300 kilowatt of sustained power and more until it is drained. A carbon-based power capacitor battery doesn't need a complex battery management system, neither does it need active cooling or heating. With lithium-ion-based batteries, on the other hand, this can take up 1/3 of the weight and volume. Hence, carbon-based power capacitor batteries are much simpler to use and much more reliable. Carbon-based hybrid power capacitor batteries, they can work from -40 degrees Celsius till +85 degrees Celsius without the need for an active thermal management system. They can also not burn, hence they are very safe and very robust. Even when discharging them at twice their maximum power, they keep working without really heating up, and that also means without destroying the battery. Carbon-based power capacitor batteries are also very resilient. Even when a cell would fail, the battery will keep working and it will never start to burn. And finally, carbon-based power capacitor batteries can be used for 10 years and more. With these outstanding qualities and already being in production, carbon-based power capacitors are an enabler and a game changer for many battery-based applications. If you want to find out more about these applications, well, watch our next video or visit our website, Energy.